Hola clase, me llamo el Señor Sapone, and today you're going to learn about slope. Yes, I know we love slope in graphing scientific data. It's so much fun. Slope. Slope is defined as rise over run. It is how much, it's the steepness of a line and how much it rises compared to how much it runs in that direction. And there's this fancy symbol here, Greek letter called delta, delta y over delta x. Delta simply means a change in. All you're doing is figuring out how much it changes from where the line starts to where the line ends. And we do that by getting a difference, by subtracting. This is our x1 and y1 position right here. This is where we start. And of course, this is our y-axis, and this is our x-axis going this way. And the line starts here at x1, y1. It ends here, and this is going to be our x2, y2 position. So really, all we want to figure is out how far this line went up versus how far it went over. And we do that by taking the y2 minus y1 and dividing it by x2 minus x1. So our y2 in this case is right up here, and we kind of match it up with where we are on the y-axis. We're right here. We are at 27. So y2 is 27 minus y1. Where's y1? Well, y1's at 0. So that's easy enough. 27 minus 0. And we do the same thing for the x. x2 minus x1. The final x position minus the initial x position. Where's x2? Right here. If we look on the x-axis to see where that lines up with, it lines up with 9. And where does it start, this line? Well, x1 starts at 0, 0, 0 on the xy axis, so 9 minus 0. 27 over 9 is going to equal 3. This line has a slope of 3. And slope, again, is a measure of the steepness of a line. If this line was steeper, it would have a higher slope. Then there's things where it could be going down, which means it has a negative slope. So slope is just kind of a measure of how steep the line is. Let's do another example. Again, slope is simply y2 minus y1. Let's find out. We start here. The line starts here. The line ends here. And this is our x1, y1 location. Again, 0, 0 for convenience. And this is our x2, y2 location. And we got to figure out y2 minus y1. Well, y2 is here. If we compare that, it looks like it's about at 16. We infer that. 16 minus started at 0. 16 minus 0. And of course, where's our x2? Well, x2 starts here. x2 minus x1. x2 is here at about 8. So 8, and we start at 0 down here. 8 minus 0. 16 over 8 equals 2. So this line is going to have a slope of about 2. The rise over the run. And we'll do one more. This one a little bit different. Now I changed up where the line starts. The initial position of the line is right here. And the final position is right here. So this is our x1, y1. This is going to be our x2, y2. So we need to figure out y2 minus y1 divided by x2 over x1. Where's our y2? Our y2 is about right here. And if we look at the y-axis, that's at about 18 on the y-axis, which is over there. And this is, of course, the x. So y2 is 18 minus y1. This time is not at 0. Y1 is actually right here. And it looks like y1 is at about 3. So 18 minus 3. We're going to do the same thing for the x variable, or the x value, x2 minus x1. x2 is up here. If we go down the graph, it looks to start at about a value of 7. So x2 is 7 minus x1, which is right here. This is our x1 value, and it finds itself right at 2 on the graph. 7 minus 2. 18 minus 3 equals 15. 7 minus 2 equals 5. 15 over 5 equals 3. So again, we have a slope of 3. Hopefully you can now calculate slope. This is Mr. Sapone. I'm out.